Okay, this is problem number 8 on chapter 10, section 1. For this problem, you need to create a scatter plot for the first part of the question. I'll be using a TI-83 this time. Okay, first of all, you need to set up this data set here on L1 and L2. Let me show you. We've done this a lot. So we go to Stat, we go to number 1, which is Edit, and set up those numbers on L1 and L2. Okay, that is the first step. After that, you go to Stat plot. To access this stat plot, you need to press the yellow key here. You press second, y equals. Well, usually, let me show you this. The first option usually is off. I mean, usually you say like this. Look, you see it here, off. You go again to this part. The default is the off. But you need to turn it on just by highlighting here on and press enter. And once you do this, the next step will be going to zoom and select number, well, in my case it's number 9, I guess, the one that says zoom fit, or zoom stat, I'm sorry, let me see, zoom stat. That's the one you need to press, number 9. And you will see the scatter plot of this data set here. So you can see that this is very close to this option right here. And the next part, they ask for the linear correlation coefficient, R. Well, for this, you need to set the diagnostic on the calculator. That's important. To do this, you press on second, 0. And you have to go all the way down to the letter D. This goes in alphabetic order. So to get closer to the letter D, we press alpha, D, I mean in this case this key. Let me see, let me press again, alpha, D, okay. So instead of scrolling down a lot of times, you can actually get closer to that option by going down, and once you find the diagnostic on, here you press enter. So by doing that, the diagnostic is going to be on, but well, this is not enough. You need to press it twice. Press enter twice. Done. When you see the letter here, the word done, means that the diagnostic mode is on. So we go to stat, we go to calculate on the right, to the right arrow, number 4, which is the linear regression, number 4, and press enter. Okay, so we present it like that, and this is the linear correlation coefficient. Okay, the 0.801. That is this number right here. Next part, determine the null and alternative hypothesis. Okay, for this one, the assumption, this is the assumption. The null hypothesis is always the assumption that there is no linear correlation when the rho is going to be 0, and the alternative is rho is different than 0. That's when you get the alternative hypothesis, right? The linear relationship. So the test statistic is obtained by using this formula. T is equals to R over the square root of all this expression, where R is this value. There is a way to bypass this formula. I mean, of course, you can always have fun and do it by hand. Let me show you how to do this by hand. I mean, you press 0.801 divided by we press second square root of well, let me open another set of parentheses because I have to do 1 minus 0.801 square. I close the first set of parentheses, divided by another set of parentheses, n, which is how many pairs you have. So we have 1, 2, 3, 4, 5, 6 pairs. 6 minus 2, we close parentheses twice, and I think that will be yeah, that's the number we obtained for the test statistic by following this formula. Okay, of course there is a way to get that number, I mean that test statistic, using the shortcut on the calculator, just by going to stat test, and the test, we go down. Actually, we can go up. If you want to reach the option faster, we go up instead of down. Let's go up. Up again. You see linear regression t-test. Okay, so press enter here, and of course x list is going to be L1, y list will be L2. The alternative hypothesis is different than 0, like here, and we press and calculate, and that's how we obtain that test statistic real fast without using the formula. Okay, the p-value is 0.055, which is this number right here. Of course, you can get the p-value in a long fashion, but well, you have this option. Well, the p-value is right there. P-value is the probability of getting a test statistic like that as extreme as the test statistic. So I don't want to go into the calculations. The p-value is right here. Let me see here. The next part is okay, the p-value is 0.055. Alpha, in this case, is 0.01, right? That's where alpha is. So we need to compare the p-value versus alpha. You see how the p-value is greater than alpha. When the p-value is greater than alpha, we fail to reject the null hypothesis. So what is the null hypothesis? Well, the null hypothesis is that there is no linear relationship. There is no hypothesis. So we fail to reject that null hypothesis. Okay, that's why here, because the p-value of the linear correlation coefficient is greater in this case than the significance level. The significance level was 1%. There is no sufficient evidence to support the claim that there is a linear correlation. So again, you fail to reject this null hypothesis of nonlinear correlation. You fail to reject the assumption that there is no linear correlation. Okay, there is no linear correlation between internet users and scientific award winners. So that's how you do this problem using a calculator. I didn't show you how to get the p-value in the long way, but in case you are curious, well, we can use this option, the TCDF. Let me see the second part. We use TCDF, and we use a lower limit of negative 10,000. I always use that number. Well, let's suppose that this is my test statistic. Let me see here. Well, let me use that one as my lower limit. 2.68, comma, the upper limit. Let me do 10,000. Comma, a degrees of freedom, which in this case will be degrees of freedom for these cases is n minus 2. So the number of pairs 1, 2, 3, 4, 5, 6 minus 2, that will be 4. Okay, comma 4, and let me see. This is what I get as my p-value, right? But it's a two-tail, so I multiply this by 2 to obtain this p-value. Let me explain that. The reason why I multiply by 2 is because, look, I know this is additional information, guys, if you want to have fun on this and really understand what is going on. The test statistic is 2.68, right? And this symbol is telling you that you have a two-tailed test. You have these two tails, right? And then the p-value is the probability. I'm sorry, I misspelled this. P-value is the probability of obtaining a t-score greater than or equals 2.68 plus the probability, let me see, probability of obtaining this value plus the probability of obtaining a value of t less or equal than negative 2.68. Okay, so because it's a two-tailed p-value, okay, so the p-value is this area plus this area. Okay, so what I did on the calculator is just basically I choose this as my lower limit and pick 10,000 as my upper limit and find this area. You remember how by using TCDF you will find this area, and by multiplying by 2, what I did here, you will combine this area plus this area. So basically that's what I did manually here, but it's something that you can obtain as well using the shortcut I showed you before, right? By going to Stat, Test, and going up and choose this option of linear regression t-test and calculate, right? So it's the same information you obtain doing the long way. So it's always good to know how to calculate the p-value, just to reinforce the concept. Okay, so this is how you do this problem.